This is topic 5-4, using graphs to build tables. Today's objective is I can use a graph to build a table and write equations describing a given situation. Your bell work is to use the objective and write an essential question. So taking our objective, we are now going to change it to a question. Instead of I can use a graph, we're going to ask how can I use a graph? To build a table and write equations describing a given situation. By the end of this lesson, you should be able to answer that question. Part 2 of the bell works is use the given words to fill in the ordered pair and the table. So our ordered pair, when we're filling in the first part, it is an X, and the second part is a Y. We're going to take the words that are listed down at the bottom and put our X's, what corresponds with the X in the X column, and then the word that corresponds with it in the Y column. So dependent is considered a Y, so we'll put that in the first Y blank. Outside is another Y, so we'll put that in the second one. What goes with dependent, X partner is independent. I'll go ahead and put that one. Independent goes with dependent. With outside, we have inside. So inside is the X part, outside is the Y. Input is another X, so we'll put it in the X part. What corresponds with it, or its Y corresponding part, is output. And last but not least, we have domain and range. Domain is the X, and range is its corresponding Y. Going from an ordered pair to a table, our first column is our X, and our second column is our Y. So we're going to transfer the words over. We have independent, it goes with dependent. Inside, its corresponding Y is outside. Input is our X, output is its corresponding Y. Domain is our X, and range is our corresponding Y. We have completed the bell work. So today we're going to start with a graph and then complete our table. So when we're talking about a graph, we do have the x-axis that is horizontal. So we'll label this X, and our vertical axis that goes up and down is our Y. That's going to help us with our headings. Our X coordinate then has a heading of hours of labor. Our Y coordinate is going to be cost for auto repair. Notice we're setting up our table just like we did before. X coordinates first, Y coordinates second. We get our titles, our headings from the labels on the graph. Next, when we read a graph, we read it as if we were reading a sentence or a paragraph. We start on the left, and we start with the point that is on the most left. If I look down at the bottom, we see 1, 2, 3, 4, 5. That means this first number must be 0. So our X coordinate is 0 for this first point. Our Y coordinate is 120. This is where we begin. That's where the graph begins. Then we have our second point. Our X coordinate is 1. Our Y coordinate is 180. The next point, X coordinate is 2. Y coordinate is 240. Our third point, or that would be our fourth point, sorry. X coordinate is 3. Y coordinate is 300. And then our last one, X coordinate is 4. Y coordinate is 360. And it looks like we can add one more where the arrow is. X coordinate is 5. The Y coordinate is 420. So what this table tells us is that At 0 hours of labor, the cost for the auto repair is $120. After 1 hour, the cost for auto repair is $180. After 2 hours, the cost for auto repair is $240, and so on. We're going to take this information in order to answer the questions that follow. Okay, to answer those questions, we will need the table. Do a little cutting and pasting. First, we need to find out what is the constant rate of change. Well, actually, first we need to find out where it began, because you will see that we are going to end up coming up with our equation. And from previous experience, we know we need to know how it begins, and then we're going to add or subtract how the rate of change, how it changes, and then times whatever that input value is going to be. This will give us our output. So we can see how it begins when we first read our chart or our graph. It began where x was 0, y was 120. Now we have to figure out our rate of change. Put change. Our rate of change means how is our output changing? My outputs are the 120, 180, 240, 300, 360, 420. So how is that changing? This is going back to when we had our pattern or the process. So to go from 120 to 180, this changed by 60. To go from 180 to 240, it changed by 60. To go from 240 to 300, it changed by 60. From 300 to 360, it changed by 60, and from 360 to 420, it changed by 60. So you will see that our output changed by 60 in every single one of these instances. That is the rate of change. It's constant because it is the same amount every single time. So our constant rate of change is going to be 60. What is the constant rate of change in words? Well, what is happening here is that we see the constant rate of change has to deal with our output. So it is the cost. Our cost did change, but it's changing per what our input was, hours. So if I go back up to my nice little equation here with words, that will help me out. I can see my rate of change is my output per my input. And I can tell that because when we think about per, this means I'm going to multiply. And up here, what I have being multiplied by the input is the rate of change. What is the equation that could be used to determine the cost of repairs? C for the hours of labor. C is our output. H, the hours of labor, is our input. So I'll go back up to what we wrote above. Our output, what we come out with, depends on how we begin. Then we are either going to add or subtract depending on our rate of change. Is our rate of change going in a positive direction or a negative direction? And then rate of change times the input. So our output is C equals, we begin at 120. Notice I'm putting in my output numbers. And our rate of change was a plus 60. So plus, we went in a positive direction. And times our input, where our input is H. So the equation is C equals 120 plus 60H. Now what is the dependent variable? The dependent variable, we know that equal is another way of saying depends on. So this could be read, our output depends on our input. That means our output is our dependent variable and input is our independent. A good thing to remember is our INs go together. So our dependent variable is the output. This is going to be the cost for auto repair. Our input is our independent. and that is the hours of labor. We can get that from our table when we labeled our X's and our Y's. Number 7 says find the cost for 7 hours of labor. Let me write my equation again. Find the cost for 7 hours of labor. You have to figure out what are they giving you. Is this a C or is this an H? 7 hours of labor is an H. So what they're giving you is that H has to be equal to 7. So our equation that I'm asking for is take your original equation, but everywhere you see an H, you will now replace it with a 7. The right-hand side, you're going to put into your calculator, and in the calculator, it will come out with that C is equal to 540. Now, our answer is we must answer the question. The question is, how much does it cost? It's going to cost $540 for 7 hours of labor. Notice how I put the dollar sign on the 540 so we know that we're talking about an amount of money. Number 8, if your bill was $840, how many hours of labor did it take? $840, that's a dollar amount. This represents C. So everywhere we see a C in our original equation, we're going to put 840. That's equal to 120 plus 60H. Now we're going into solve mode. It wants us to find out how many hours. So what we need to find out is our H. We'll draw a line down our equal sign. We don't have any parentheses. We don't have any like terms to combine. And we see H only on one side. So we skip to the step where it says put a box around the term and the variable. Get rid of the number that's not in the box. That's going to be the number on the same side, not in the box. That's the 120. 120 is positive, so that means we need to subtract. 840 minus 120 gives us 720. 120 minus 120, that is 0. I don't need to show the 0. What I still have left is the 60H, which is still in the box. Our last step is to do the opposite of the term that's with the variable in the box. We have a positive 60 times H. So in order to get rid of the positive 60, we must do the opposite of times, that's divide. So we will divide by a positive 60. We'll divide both sides by positive 60, and that will give us that H then is equal to 720 divided by 60 is 12. So now we must answer our question. The question is, how many hours of labor did it take? It took 12 hours for the bill to be $840. Now let's summarize our learning. Let's refer back to the essential question. The question was, how can I use a graph to build a table and write the equations describing a given function? So the answer, I can use a graph to build a table and write the equation describing a given situation by, first thing we did was put the points, let's see, we read the graph from left to right. Should we write RIGHT, putting the points in the table. We determine our beginning point. So determining the beginning point, that was the first point on the graph, and the rate of change. I must do that third. We determine the rate of change. And the way we determined the rate of change was we looked at how did the output change. Then we wrote our equation by saying our output is equal to how we begin plus or minus the rate of change times the input. Remember, the plus means we did a positive rate change. It changed in a positive direction. Negative is if it changes in a negative direction. This concludes topic 5-4.